Hello, this lesson is on section 1.5, solving linear and absolute value equations. Okay, so in a previous video you may have watched, we talked about what an expression was, and we said an expression didn't have an equal sign or an inequality sign. So you simplify an expression. But what if you have an equation? Well, an equation is two expressions set equal to each other. And an inequality is two expressions that have a greater than or equal to or not equal to set to each other. All right, so what does it mean to solve an equation? Well, you can think of it in two ways. When you're trying to solve an equation, what you're trying to do is get the variable, or x, we'll say, even though it can be a different variable, by itself, all alone on one side, so that we know what x is. Or you can think of it as this. When you're asked to solve an equation, you're asked to find the values of x that make the statement true. So you can think of an expression as a phrase and an equation as a sentence. Okay, so the golden rule of algebra when you have an equation is whatever you do on one side, whatever you do to one side, you have to do to the other. Okay, so whatever you do on one whole side, not each term, but one whole side. Okay, so we will solve several different types of equations. And each type has a different method. And linear equations are what we're going to start with, and then we're going to move to absolute value equations in this video as well. But there are also radical equations, quadratic equations, and rational equations, and they're all in this unit. So if you have these different types of equations, you use some different methods. So it's important to start by saying, okay, what kind of equation am I trying to solve? Okay, so we'll start with solving linear equations. So what is a linear equation? Well, the word linear means that the exponent on the variable is just 1. Okay, these are also called degree 1 equations. And you solve a linear equation by using inverse operations. And the word inverse operations means the following. So what is the inverse operation of addition, or the opposite of addition? Well, that would be subtraction. Because subtracting something will undo adding something. Or, like we said in the last video, the opposite of addition is also adding the opposite. And the opposite or inverse of multiplication is division, or multiplying by the reciprocal. So you always want to be thinking about what is happening to x. What is the operation that the numbers that you see are doing? And you want to undo what's being done to the variable. And you might be familiar with PEMDAS. So PEMDAS is a way of remembering the order of operations, which is the ultimate authority in the order in which we are allowed to do things. So if you are just simplifying something, you have to do parentheses first, and then the exponents, and then multiplication and division from left to right, and then addition and subtraction from left to right. Well, when you're solving an equation, this process is reversed. Think of it this way. Look at number 1. So there's your variable x. Now, x stands for a number, and right now it's a mystery. And the first thing, if you were to put a number in for x, you would multiply 5 to that number because you have to multiply before you subtract. So the first thing that would happen to x is it would be multiplied by 5. Then you would take that result and then subtract 6. So the first thing is multiplication and the second thing is subtraction. Well, when you're trying to solve for x, that process is reversed. So we are going to not get rid of the 5 first. We're going to get rid of this minus 6. And this is where you do the opposite of what you see. So if you have a minus 6 and you want to get rid of it, you can add 6, but it's an equation. So whatever you do on one side, you have to do exactly the same thing to the other side. And so we get 5x equals 15. And you get something called an equivalent equation. And so you start over and you look at that equation. You have 5 times x equals 15. Well, you undo multiplication with division. And we don't use the little division sign. We use a fraction bar. That's division. And so 5x divided by 5. Well, 5 divided by 5 is 1x. And then 15 divided by 5 is 3. So we have solved this linear equation. This is called a two-step equation because you had to do 2 things to get x by itself. Okay, so you might want to try this one. All right, so on the left side is a 4, and on the right side is 5 times x plus 8. And it's all about getting x by itself. So 5 times x is the first thing that happened to x, and then plus 8 is the next thing that happened. Well, we want to undo this in reverse, so we're going to undo the plus 8 by subtracting 8. And then whatever you do on one side, you do to the other. And that would give you 4 minus 8, which is a negative 4. And then 5x plus 8 minus 8, that gives you 0, so there's 5x is left. And you get another equivalent equation. Okay, now you have 5 times x. So we're looking at what's happening to x. 5 is being multiplied to x, so we're going to undo that by dividing both sides by 5. And over here, 5x divided by 5, that divides out to 1. And this is the value of x. Now this is a fraction, negative 4/5. And in Math 171 and advanced math classes, we prefer the fraction answer. So we're going to leave it negative 4/5. It is true that the answer is negative 0.8 as well. Wouldn't count that off. But if the answer was 1/3 and you told me 0.33 repeating, that would result in losing some points because we want the value to be exact and not rounded. All right, let's look at number 3. So here, if you look at x, the first thing that happens to x, it's being divided by 2. So if you put 12 in here, or 18 in here, 18 divided by 2 would be the first thing you do. That's 9. And then you would subtract 6, right? So we're going to undo what's happening to x in reverse order. So we're not going to multiply both sides by 2 this time. We're going to get rid of that minus 6 by adding 6 to both sides. And another way you can think of this is there are 3 terms. We talked about terms in the last video. And if you want to get the x term all alone first. So this minus 6 is this term, you want to get rid of it. And so you can add 6 to both sides. And that gives you x over 2 equals 1 because negative 5 plus 6 is 1. Okay, now what's happening to x is being divided by 2. So we're going to multiply, because that's the opposite of division, we're going to multiply both sides by 2. Now when you multiply by 2, when if you're looking at a fraction, you have to understand that you can make anything a fraction by putting it over 1. So that 2 is in the numerator, and that 2 right here is in the denominator. So 2x divided by 2, these 2's cross cancel out. 2 divided by 2 is 1. So that's going to work to get x by itself, and then you get 1 times 2 is 2. Now, we've succeeded in getting x by itself, right? Okay, what the second thing means, solutions are things that make this statement true. So you could check your work if you wanted to, but we're stating that 5 times x minus 6 is equal to 9. And the only value of x that's going to make that a true statement is 3. So if we check our work, we get 5 times 3 is 15, and 15 minus 6 is indeed 9. So we found the value of x that makes that statement true. Okay, now let's look at 4. So 4 says 2/3 times p minus 6 equals 18. All right, so the first thing is 2/3 times p and then minus 6. Or we want to get this p term by itself. So we should all be knowing that you're going to add 6 to both sides. And that gives you 2/3 p is equal to 24. Okay, so now you have an equivalent equation. So now we're going to do something that some of you may not remember how to do, but this is a fraction that's multiplied to p. So yes, the opposite of multiplication is division, but when I have a fraction, I would prefer not to divide by 2/3. What I would prefer to do is remember that just like subtraction is the same as adding the opposite, division is the same as multiplying by the reciprocal. So what's the reciprocal? Well, a over b and b over a, those are reciprocals. Okay, so if I want to get p by itself, I can remember this trick that I can multiply this side to, I want this to go away. I want this to become a 1p, right? So if I multiply by 3 over 2, then that's going to give you 6 over 6. That's 1, right? But then don't forget the golden rule of algebra. Whatever I do on one side, I have to do on the other. Okay, so over here, this 3 divides out with that 3, and this 2 divides out with that 2. You're left with 1p. Okay, and then you can use your calculator. At any time, you can use your calculator. So if you don't like the fraction math, you just can put it in 24 times 3 divided by 2. And you can get an answer. But you should kind of know what's going on here. Again, 24, you can make a fraction by putting it over 1. So now you can do something, if you're multiplying, you can do something called cross-canceling. Multiplication and division play nice together. So you can think to yourself, well, this 2 goes into itself once, and this same 2 into 24 goes in there 12 times. And then 12 times 3 is 36 over 1 times 1, which is 1. So you get 36. All right, this next one kind of challenges us because it's different than anything that we've seen before. And so this is why I've been asking you to think about PEMDAS, but in reverse to solve. So you have this x here, some number minus 6 is the first thing, because that's a grouping symbol. That division is kind of like grouping it. It's saying, hey, well, you do this first. So the first thing that's happening to x is this time it's being minus 6. So some number minus 6. And the second thing is divided by 3. So you have to do that in reverse, right? So we're going to have to get rid of the division by 3 by doing the opposite. That's what we'd have to do first. So, and remember, it's the entire side, whatever you do on one whole side. So I'm going to multiply both sides by 3. And the whole purpose is I know what's going to happen. 3 times this divided by 3, these 3's divide out to 1. And that leaves you with x minus 6. And then 3 times 5 is 15. So we create an equivalent equation. So whatever you do on one side, do on the other. You create an equivalent equation. All right, so now we would just add 6, and you get x is 21. Okay, so what if there are variables on both sides of the equal sign? What you want to do first is, remember we learned about simplifying expressions? Well, you want to simplify the expression on each side before you begin to get rid of things. And then this is optional, but it's going to be helpful to know later on. So I'm going to teach you how to eliminate any fractions. And then once you've got the equation as simplified as you can, each side, and no fractions, then you're going to start moving like terms to the same side of the equation. Okay, so this first one, 5x minus 6 equals 9x plus 3. Remember, our goal is to find out what x is to get x all alone on one side. Well, you've got x's on two sides. So it starts to become helpful to think in terms of terms, which we talked about in the last video. So I see 4 terms. Hopefully you do too. I see a 5x term, and a minus 6 term, and a 9x term, and a plus 3 term. So you can move terms over onto the other side of the equation. If you remember that whenever you move a term over the equal sign, it's going to change sign. It's like a sign changing box. So you move that. If you want to move the 5x over here, then that is going to go over there. So you would write, okay, there's a negative 6 term equals a 9x term plus a 3 term minus a 5x term. You still have 4 terms. You just moved this term, this x term, over on the same side of the other x term. And then you simplify. So you can start to do that in your head. So 9x minus 5x is 4x plus 3. And then you have a 2-step problem. Okay, so that's how we're going to do it. I'll do this again. Okay, the reason that works is because you may have learned this way. It's kind of a play on how we did the other one. So if you have an x on one side and another x term on the other side, what you want to do is you can think of, I want to get rid of one of these x terms. So the opposite of positive 5x is minus 5x. And whatever you do on one side, you do on the other. So 5x minus 6 minus 5x is negative 6. And 9x minus 5x is 4x plus 3. So you see, you get the same thing whichever way you do it. But I like to move terms over by changing the sign, because that's going to be more helpful for us. All right, let's continue. We have negative 6 equals 4x plus 3. So we're going to get rid of this plus 3. We don't care what's going on over here. We want to get x by itself. We need to get rid of the 4 that's being multiplied, the 3 that's being added. Which one would you do first? The minus 3. That gives you negative 9 equals 4 times x. And divide by 4. And you get x is equal to negative 9/4. Okay, this is what's called an improper fraction, and that's an unfortunate name because once you get to this level, this is actually the better form. I don't like mixed fractions because written this way, negative 9/4 is really just one operation, negative 9 divided by the 4. If you write that as a mixed number, that would be negative 2 and 1/4, which really means negative 2 plus 1 divided by 4. So it makes it very difficult for us to continue on if we need to. Now this will be helpful if you were to graph it on a number line. It's helpful to know what this is. But we like to just leave our answers reduced, but just improper. So negative 9/4 is a good final answer. Okay, so number 1, we did not have to do this first step, simplify the expressions on each side of the equation first, but we do have to do that here. And this is where we also need to make sure we follow the PEMDAS order of operations rule, because some people might be tempted to add the 5x plus the 8. But it's important for every step you think about the operation. So what's going on here is you have 8 being multiplied to this parentheses. And you are supposed to multiply before you add. So you cannot add 5x plus 8. That would be going out of order. All right, so the first thing we have to do is simplify what's going on the right-hand side. So 5x, you can't deal with that, so that's 5x plus. What we're going to do is multiply first, and you do that with the distributive property. So that's 8x minus 24. And then you look, and it's still we're not ready to solve yet. We're still simplifying the expression on this side. So we have 4x equals 13x minus 24. They're on the same side. So I like to say you don't need to get rid of them. You wouldn't do minus 5x minus 5x. Some people do that, but that's actually subtracting 5x twice on the same side. That breaks the golden rule of algebra, so that's not it. So I always kind of say these two terms, they're on the same side. They shake hands. They're on the same side. They shake hands. So 5x plus 8x gets simplified, and that's 13x. Okay. So now we're back to the problem that we had before. We have a variable, an x term on the left and an x term on the right. Now, I would not move the 4x term because there's no other terms on the left, and then you'd have to put a placeholder of 0. So I got to notice that. So I'm going to move this over here, which would become negative 13x plus 4x. Okay, or you can show your work. So you're going to subtract 13x from one side and subtract 13x from the other. They cancel, and 4 minus 13, that's negative 9x, and then it equals negative 24. All right, so then negative 9 times x, we're going to divide by negative 9. So you want to divide by the same side because you remember you want this to become a 1x. So negative divided by negative is a positive 1x. And then a negative divided by negative is a positive 24 over 9. Now, I know my times table is pretty good, so I already know you can reduce this. So if you put 24 over 9 down, you're probably going to lose a point or half a point. You have to reduce. And what I mean is your calculator will do it for you. If you put in 24 divided by 9, it's going to give you the equivalent value. Now, notice that it gives you 2.666 repeating. Don't put that on the paper. That would be an approximate answer because you have to round. What you're going to do is on this calculator, there's a little squiggle right here, right above the enter. And if you hit that, what it's going to do is it'll turn the decimal back to a fraction. So you get this fraction 8/3. So 24/9 reduces to 8/3. Now, you don't need a calculator for that. What you can do is you can think, well, what is the number that they both have in common that I can divide out? And they both are divisible by 3. So you have to find that number, and 24 divided by 3 is 8, and 9 divided by 3 is 3. But again, hit the little squiggle, and your calculator will reduce fractions for you. So x is 8/3 there. Okay, now the next one, we have an x on the left, x divided by 2, and an x on the right, 7x. But we also have something new, and there's a little trick you can use. The golden rule of algebra is really helpful. You have power when you have the equal sign. You're not stuck with what you have. You can get rid of the thing that's bothering you. So if you see a fraction, this division by 2 makes that a fraction, you can get rid of that by multiplying both sides. Both sides. So I put parentheses about both sides, and I don't like that division by 2, so I'm going to multiply both sides by 2. Now, you have to do this correctly. When you do that, you have to remember I'm multiplying both sides by 2, and we know something called the distributive property for multiplication over addition and subtraction. So you have to remember to distribute that 2. And this uses the good old cross-canceling. See, 2 over 1 times x over 2, those 2's cancel, and you're left with x. And then here, 2 times minus 6 is minus 12. So I need the 2 over 1 when I'm thinking about multiplying it to a fraction. I don't need the 2 over 1 when I'm just multiplying it to 6. But then don't forget, whatever you do on one side, you have to do on the other to keep the equations equivalent. So now I'm going to distribute this 2, and that would be negative 10 plus 14x. All right, so now you might want to add the understood 1, and it's just like before. All right, I'm going to move I've got x terms on opposite sides. So I'm going to move this 1x term over here. It becomes negative 1x when you move it over that sign changing box. Okay, so that's got moved. That's negative 12 is equal to negative 10 plus 13x. Okay, so now I just have 1x, a 13x term. So I need to, don't look over here. You're worried about x. How would you get x by itself? Well, you wouldn't want to get rid of the 13 first. That's the first thing happens to x. And then the minus 10 got added. So we want to get rid of this negative 10. And the opposite of negative 10, remember, is adding positive 10. Whatever you do on one side, do the other. And that gives you negative 2 equals 13x. Okay, now we can divide both sides by 13. And x is negative 2 over 13. Again, we wouldn't want a decimal. We're going to leave it like that. Okay, so here comes one that's really complicated. You have 2 divided by 3, 2/3 times p. Well, if you have an equal sign, I can get rid of that fraction. If I remember, I can do whatever I want on one side as long as I do it to the other. Now, this is kind of complicated. So you have a choice. You might say, I want to get rid of this 3 right away, or you might say, I want to distribute this 6. I think it's going to be a little clearer if we distribute first. So this 2/3 p, we'll deal with you in a minute. Okay, now remember, this is a negative 6, so you might want to change your sign. Subtraction is the same as adding the opposite, because you don't want to forget to distribute that negative. Miss Mills has top 5 errors people make. Number 1, people forget to distribute the negative to both terms. So whatever you need to do, you need to know that that's a negative 6. Minus 6 means negative 6. So I'm going to make that plus a negative. So negative 6 times p is negative 6p. Negative 6 times negative 2 is positive 12. Over here we can distribute 8p plus 40. Okay, so now I've got how many terms? 1, 2, 3, 4, 5. So I think that's simplified enough to show you my little trick. And that is, I can get rid of this fraction. This 3 is bothering me. If I can remember how to get rid of that 3, I can multiply this side by 3. But whatever I do on one side, I have to do to the other side. Okay, so then that means I'm going to have to distribute that 3. And the whole purpose, remember 3 is 3 over 1. So 3 over 1 times 2 over 3 is just 2p. All right, I shouldn't cross that out so aggressively because remember we have to distribute 3 times negative 6. So that's negative 18p. And then 3 times 12, that's 36. And then over here, 3 times 8p, that's 24p. And then 3 times 40. You can always have your calculator nearby. I tell my students, I teach you the algebra. You can let the calculator do the arithmetic. Okay, so here we go. We have this equation. Now you got to look every time you do something, you create an equivalent equation. You have to look at what you got. You have to take your time. So you see how you have 2p terms on the left? Well, they need to shake hands. So 2p minus 18p is negative 16p plus 36 equals 24p plus 120. So now I'm ready to start moving terms around. I've got negative 16p on the left and 24p on the right. So I'm going to move this term over or add the opposite. I'm going to add 16p to both sides. So that's 36 equals, you can have that calculator right nearby. You get 40p plus 120. So 36 equals 40p plus 120 is a new equivalent equation. So I want to get p by itself. I'm not going to get rid of the 40. I'm going to get rid of the 120 first. So minus 120 minus 120. Here's your calculator. 36 minus 120 is negative 84. Negative 84 equals 40p. There's a new equivalent equation. We're going to divide both sides by 40. Going to reduce that. So I'm going to put that in the calculator. It'll reduce for me. Negative 84 divided by, so that division, that's a division symbol, 40. All right. And it gives me negative 2.1, and that's a terminating decimal. If you wrote that down, I would not count that wrong, but I like the fraction better. So P is equal to negative 21 over 10. So you have to make sure you reduce. Okay, so that's it for solving equations. The next video, we will talk about absolute value equations.